Here we have Precalculus Lesson 7, Part 4, Graphs of Polynomials. And in this lesson, we'll actually start graphing polynomials, starting with sketching a rough graph of f of x equals x squared times x plus 1 times x minus 2 cubed. To graph this function, you might realize, first of all, that this is the same function that we found zeros and multiplicities for in our last video. The zeros are -1 of multiplicity 1, 0 of multiplicity 2, and 2 of multiplicity 3. We're going to go on then to look at the end behavior here, and you can see that we have x squared times x to the first power times x to the third power, giving us our end behavior. We simplify to get x to the sixth here. So the end behavior is going to be like y equals x squared. And that means that as we go to the left, our graph is going to head up. Also, as we go to the right, our graph is going to head up. We're going to next look for the y-intercept. For the y-intercept, we set x equal to 0. And so y would equal 0 squared times 0 plus 1 times 0 minus 2 cubed. And 0 times anything is going to give us a y-intercept of 0, which is the point on our graph of 0, 0. We could have already guessed at that since we have an x-intercept at that point, but let's go ahead then and graph what we have here so far. So we have the points on our graph. The 0 of -1 tells me that I have an x-intercept at -1, 0. The 0 of 0 tells me that I have an x-intercept at 0, 0. The 0 of 2 tells me that I have an x-intercept at 2, 0. Okay, and so the multiplicities, what we're going to do to help us graph, we're going to look at whether the multiplicities are even or odd. 1 is an odd number, 2 is even, 3 is odd. If a multiplicity is odd, the graph will cross the x-axis at the corresponding x-intercept. If the multiplicity is even, the graph simply touches and bounces at that point. And again, we have an odd multiplicity at x equals 2. Okay, so let's see if we can sketch this graph using the end behavior. To the right, we're going to be heading up. And at x equals 2, our graph is going to simply cross. Okay, so we're going to come down. We're going to cross at x equals 2. At x equals 0, our graph will touch and bounce. And then at x equals -1, our graph is going to cross. Okay, so we have a graph of this function. It's a rough graph. And what we're looking for in these graphs is we want to hit the x-axis and the y-axis at the intercepts. And we want to also make sure that our graph, where it's should be above the x-axis, it's above the x-axis. Where it should be below the x-axis, it's below the x-axis. And as with any polynomial, we want a nice, smooth, connected curve. Now let's try a graph of g of x equals -3 times x minus 2 times 2x plus 1 squared. And we're going to start here by finding the zeros and their multiplicities. Notice that the x values that would cause this function to become 0 would be x equals 2. X equals 2 has a multiplicity of 1. And from the factor here, 2x plus 1, we would get a 0 of -1/2. That 0 is going to have a multiplicity of 2. Let's go on then to determine the end behavior. The end behavior would be like -3 times x raised to the first power times 2x squared. We'll simplify there to get -3x times 4x squared, which would be -12x cubed. Now -12x cubed, we have an odd power but a negative coefficient, so we would think of y equals x cubed but reflected about the x-axis to give us y equals -x cubed. And as our graph goes to the left, it heads up. As our graph goes to the right, it's going to head downwards. Then let's see if we have a y-intercept here. Our y-intercept, we would set x equal to 0, so we would have y equals -3 times 0 minus 2 times 3, 0 minus 2 times 2 times 0 plus 1 squared. And that would give us negative 3 times negative 2 times 1, it looks like. We get, simplifying, we end up with 6. So our y-intercept is a point on the graph 0, 6. Let's go ahead and start by plotting the y-intercept here. 0, 6. Our other intercepts are going to come from our zeros of 2. So we have an x-intercept at 2, 0, and our other 0 is negative 1/2, so we would have an x-intercept at negative 1/2, 0. Our multiplicity of 1 is odd. Our multiplicity of 2 is even. I don't really need to use the end behavior here. With the y-intercept, we see that we're above the x-axis between x equals negative 1/2 and x equals 2. So let's use that, and I'm going to double check. So at x equals 2, my multiplicity is odd. So I'm going to go from my y-intercept down here. I'm going to cross at x equals 2. And at x equals negative 1/2, an even multiplicity tells me I want to simply bounce off the x-axis at that point. So our graph is going to look something like this. And this is it. So we do check the end behavior, though, maybe at the end to see we are heading up as we go to the left, and we are heading down as we go to the right. Let's go on and look at the next try on your own for today. This is number 4. Sketch a rough graph of the function f of x equals 2x times x minus 2 squared times x plus 2. And we'll go on to create a polynomial p with the following characteristics. First of all, the solutions to p of x equals 0 are x equals 2, x equals negative 3, and x equals plus or minus 4. Then the leading term of p of x is negative x to the 5th. And thirdly, the point negative 3, 0 is a local maximum on the graph of y equals p of x. So let me change colors here, and let's do it. So p of x is going to equal, I'm going to throw an a, my leading coefficient, out in front here, or I think it will be my leading coefficient. Let's see what factors we get. If x equals 2 is a 0, then x minus 2 will be a factor. If x equals negative 3 is a 0, then x plus 3 will be a factor. If x equals 4 is a 0, then x minus 4 is a factor. And if x equals negative 4 is a 0, or is a solution to p of x equals 0, then x plus 4 is a factor. The next thing we're told is that the leading term is negative x to the 5th. I'll take care of the negative in just a minute, but for now, let's look at that 5th power. So at this moment, we would only have the 4th power on p of x if you look at it. To get that 5th power, we're going to use the fact that the point negative 3, 0 is a local maximum on the graph of y equals p of x. That means if I sketched a graph of this function, I'm just going to do that one little part here. At the point negative 3, 0, the graph is going to come up and simply touch the x-axis at that point. So at negative 3, 0, our graph comes up, touches, and goes down. It bounces at that point. That tells me that at negative 3, 0, my 0 of x equals negative 3 has an even multiplicity. So I'm going to take my factor of x plus 3 here and put a 2 on there. That's the lowest even multiplicity that I can use here. And that actually then would give us a degree of 5 for our polynomial. So let's look at what the leading term here would be. The leading term of our polynomial would be a times x raised to the 1st power times x squared times x raised to the 1st power times x raised to the 1st power, or it would be a times x raised to the 5th power. We're told that the leading term is negative x to the 5th, so let's just write a x to the 5th equals negative x to the 5th. We can see that a is going to equal negative 1. Now I can finish off the polynomial. I can write that as p of x equals negative of, I could write -1 in parentheses if I wanted to, but I'll just put negative of x minus 2 times x plus 3 squared times x minus 4 times x plus 4. And we have it. Okay, so as always, if you have any questions, please don't hesitate to ask. And I hope you're having a great day.